Hello and welcome back. We're going to continue our discussion with the Oliver Heaviside method of using partial fractions to help us integrate. Now, this one's a very special case because unlike in the other examples, if you notice down here, we have a quadratic factor. And you might recall in another video I said it was a little bit different, like right over here, where the bottom we have this x plus 1 squared. This is still considered a linear factor because the degree on x is still 1. But over here, the degree on x is 2. So this is a quadratic factor. So what that means for us, if we have a quadratic factor, is that the top of the fraction has to have a degree of 1 when we decompose this. When we decompose it, we have to have a degree of 1. In other words, the top is going to be linear. So let's see what that will look like in terms of our problem. So we're just going to work on the decomposition. 7x squared plus 5x plus 23 over x plus 1 times x squared plus 4. When we decompose this, remember, we have two factors. Now each factor only has a degree of 1, so we only need 2 fractions. So we're good like that. So the first one is going to be x plus 1. Now remember, this is a linear factor. So its numerator is going to have a degree of 0, or just a number. We'll call that a. We don't know what it is yet. Plus, now the second one, it has a quadratic factor. So the top here must be linear. In other words, it has to have a degree of 1. So where this one is really, degree of 1, where this one has like x to the 0, I'm going to go bx. So that makes it linear because now the power there is 1. But there's more to it. Remember the equation of a line, y equals mx plus b. So we have to add a 0, or a 0 degree term there too. So we go plus c. Because there might be a y, or there might be another value there to make it a line. So when we do the LCD, nothing else is going to change. So now we're just like the last one though, we have 3 variables to solve for, a, b, and c. So we're going to multiply by the LCD. We're really good at this now. We made the LCD, or they gave it to us, and that's going to be the x plus 1 and the x squared plus 4. And that's going to give us 7 x squared plus 5x plus 23 equals a times x squared plus 4 plus this bx plus c times this x plus 1. Now be very careful. Notice I put the bx plus c in parentheses. This is going to become very important for us later on. Okay, you want to have that, I promise. That's my hint. Alright, so let's get busy. So, the Oliver Heaviside method, sounds like it's a memorial, the Oliver Heaviside Memorial. The Oliver Heaviside method, he says that, well, in order to solve for a, b, and c, we will need to pick 3 x values. Any x values will work, okay? So, he said, but the easy way he said is to pick the zeros. But if you notice, there's only going to be one 0 here. X squared plus 4 does not give us a real 0. It gives us an imaginary, but we don't want to deal with imaginary numbers. So we're only going to have the 1 0. So there's only 1 0. Since there's only 1, we might as well use it. And that's going to be x equals negative 1. And if we plug that in, 7 minus 5 plus 23 equals, this becomes 5a, and this all becomes 0 right there. And if you solve it, this becomes 2. 2 plus 23 is 25, divided by 5. A is 5. Alright, so we already got one variable out. And I can so the next we have to do is find b and c. Now that's going to get where it gets a little bit more fun for us. So to find B and C, to find these both, we have two options. option 1, and this is what most books will probably do. They say pick 2 x values, 2 additional x values. Keep them easy. 0 would be an easy one, or we already used -1, so you can use 1. Keep them easy. And then you can solve the system and solve. Now, most books will probably teach it that way, but there's a secondary option that we can use, and that's involving algebra. We can let a equal 5, and we're just going to plug in. And that's what we're going to do. If we let a be 5, and we're just going to plug this in, we're going to get 7x squared plus 5x plus 23 equals, if I plug a in, I'm going to get 5x squared plus 4 plus bx plus c times x plus 1. Next, I'm going to use my algebra. I am going to distribute the 5. Do not distribute this. Okay? Don't distribute that. That becomes a mess. That's ugly. We don't like that. That's going to give me 7x squared plus 5x plus 23 equals 5x squared plus 20 plus bx plus c x plus 1. Bring all this over. I'm going to get 2x squared plus 5x plus 3 equal to bx plus c times x plus 1. You kind of see where I'm going? This is factored. Let me factor this and let's see what happens. If I factor 2x plus 5x plus 3, we're going to get 2x plus 3 times x plus 1. And notice that's going to be equal to the right side. These must be equal. And if they're equal, what does that tell us? That the factors are equal. And if the factors are equal, well, I know that the x plus 1 equals this x plus 1. I also know that this 2x plus 3 equals this bx plus 3. So I can say 2x plus 3 equals bx plus c. And therefore I got my b, which is 2, and my c, which is 3. This always works out. Man, that Heaviside was a genius. Alright, now remember, that's the long part, right? Now we have to actually integrate it. Alright, so let's see here. There is my rule. A over x plus 1, bx plus c over x squared plus 4. So I'm going to write that out here. So my new integral would be 5, which we said a was 5 over x plus 1 plus b x plus c, which is 3, over x squared plus 4 dx. Alright, so I need to think, okay, this one's easy. That's just natural log. That's easy. I can do that one with my eyes closed. But this one right here, take a look. If I did use substitution, my u would be 2x. They're exactly the same. That's a u substitution if I can get rid of the 3. So I'm going to get rid of the 3 by splitting the fraction. This problem has it all, right? Okay, the longest problem you're ever going to get. So I can split that fraction. And that's going to give us 5 over x plus 1 plus 2x over x squared plus 4 plus 3 over x squared plus 4 dx. And what do we have? Well, that's our u sub. That's a u sub. And this one should look like our arc tangent. Right there, that's our arc tangent rule. So let's do this one. Ready? Here, u is going to be x plus 1. My du is dx. So that's easy. The first one is just going to give us 5. This becomes 5 over u. Natural log of x plus 1 plus, let's see here, u here is going to be x squared plus 4. Du is 2x dx. Those cancel. And remember, this becomes 1 over u, so we're left with the natural log of x squared plus 4. We're doing that shortcut. Plus 3, this is my arctangent rule. U is x, du is dx. We checked it off. Always check to make sure you're not dividing by anything. A is 2. And remember, arctangent is 1 over a, arctangent u over a. So it's 1 over a, which is 2, arctangent u, which is x, over 2, plus c1. Look at that antiderivative. Notice the antiderivative is really not all that hard to do. But it's this process that's lengthy, okay? Alright, hope you enjoyed the video. Work on a few of these. I'll see you guys soon. Bye-bye.